Technology and livelihood education, information and communication technology. Our topic is software application.
Gather round, everybody, it's time to learn. We're diving into TLE, it's your turn. Technology, livelihood, education so bright. Come on, let's make it fun, everything feels right. TLE, we're on a roll, lifelong learning is our goal. ICT and electricity, we're crafting futures, can't you see? Agriculture and fishery, it's all so cool, come sing with me.
The following are the objectives of today's lesson. Review of the previous lesson. Which of the following telecommunication devices is responsible for routing data between devices on a network and converting digital signals for transmission? A. Switch, B. Modem and router, C. Antenna, D. Repeater. Number 2. Mark is repairing a desktop computer. Before opening the CPU case, he wears a tool to prevent damaging internal parts due to static electricity. What tool did Mark most likely use? A. Screwdriver, B. Multimeter, C. Anti-static wristband, D. Cable tester. Number 3. Anna is designing a poster for their school event. She wants to use software that allows her to create and manipulate vector graphics. Which tool is most appropriate for Anna's task? A. Git, B. Visual Studio Code, C. Node.js, D. Adobe Illustrator. Number 4. Why do many computer programmers use 2 or more monitors while programming? A. To play games on one screen while coding on another. B. To make their computer look more advanced. C. To view code, documentation, and output simultaneously for better efficiency. D. To increase the brightness and color quality of the display. Number 5. Which hand tool is commonly used to remove or tighten screws when assembling or repairing computer hardware? A. Multimeter, B. Screwdriver, C. Anti-static wristband, D. Cable tester. Behind the screen are the hidden power of computers. What do you think makes a computer work when you turn it on? What do you think are the invisible parts of a computer that make it perform tasks or respond to your commands? The invisible parts of a computer are the software and the data stored inside. Software includes the operating system, programs, and apps that give instructions to the hardware. These programs tell the computer what to do, like opening a game or typing a document. Without software, the computer wouldn't know how to perform any tasks. Do you think the hardware parts of a computer can function on their own? Why? No, the hardware parts cannot function on their own. Hardware needs software to tell it what to do. A computer operates and performs tasks because of the teamwork between hardware, like the CPU, memory, and storage, and software, like the operating system and applications. Software gives commands, and hardware follows them. Without software, the hardware would just sit there and do not. If hardware is everything you can touch, what do we call everything you can't see that tells the computer what to do? Our topic is software applications, application software, and system software. Software is a set of instructions, data or programs used to operate computers and execute specific tasks. It is the opposite of hardware, which describes the physical aspects of a computer. Software is a generic term used to refer to applications, scripts, and programs that run on a device. It can be thought of as the variable part of a computer, while hardware is the invariable part. The two categories of software. 1. An application is software that fulfills a specific need or performs tasks. And number 2. System software is designed to run a computer's hardware and provides a platform for applications to run on top of. An application software is the most common type of software. It is a computer software package that performs a specific function for a user, or in some cases, for another application. An application can be self-contained, or it can be a group of programs that run the application for the user. Examples of modern applications include office suites, graphics software, databases and database management programs, web browsers, word processors, software development tools, image editors. System software. These software programs are designed to run computer application programs and hardware. System software coordinates the activities and functions of the hardware and software. In addition, it controls the operations of the computer hardware and provides an environment or platform for all the other types of software to work in. The OS is the best example of system software. It manages all the other computer programs. Other examples of system software include firmware, computer language translators, and system utilities. The driver software. Also known as device drivers, this software is often considered a type of system software. Device drivers control the devices and peripherals connected to a computer, enabling them to perform their specific tasks. Every device that is connected to a computer needs at least one device driver to function. Examples include software that comes with any non-standard hardware, including special game controllers, as well as software that enables standard hardware, such as USB storage devices, keyboards, headphones, and printers. Number 4. Middleware. The term middleware describes software that mediates between application and system software or between two different kinds of application software. For example, middleware enables Microsoft Windows to talk to Excel and Word. It is also used to send a remote work request from an application in a computer that has one kind of OS to an application in a computer with a different OS. It also enables newer applications to work with legacy ones. Number 5. Programming software. Computer programmers use programming software to write code. Programming software and programming tools enable developers to develop, write, test, and debug other software programs. Examples of programming software include assemblers, compilers, debuggers, and interpreters. How does software work? The software will give instructions, then send it to the hardware. The CPU will execute, then will show the output to the user. The following are the key characteristics of software quality. 1. Accessibility. The degree to which a diverse group of people, including individuals who require adaptive technologies such as voice recognition and screen magnifiers, can comfortably use the software. 2. Compatibility. The suitability of the software for use in a variety of environments, such as with different OSes, devices, and browsers. 3. Efficiency. The ability of the software to perform well without wasting energy, resources, effort, time, or money. 4. Functionality. Software's ability to carry out its specified functions. 5. Installability. The ability of the software to be installed in a specified environment. 6. Localization. The various languages, time zones, and other such features a software can function in. 7. Maintainability. How easily the software can be modified to add and improve features, fix bugs, etc. 8. Performance. How fast the software performs under a specific load. 9. Portability. The ability of the software to be easily transferred from one location to another. 10. Reliability. The software's ability to perform a required function under specific conditions for a defined period of time without any errors. 11. Scalability. The measure of the software's ability to increase or decrease performance in response to changes in its processing demands. 12. Security. The software's ability to protect against unauthorized access, invasion of privacy, theft, data loss, malicious software, etc. 13. Testability. How easy it is to test the software. 14. Usability. How easy it is to use the software. Considering how application software and system software work together, explain the following. Why both are essential for a computer to operate effectively. What would happen if one existed without the other? Both types of software are essential because they depend on each other. System software manages the computer's hardware and provides the environment for applications to run, while application software allows users to perform tasks like writing documents or browsing the internet. Without system software, applications wouldn't have a platform to run on. Without application software, users wouldn't be able to use the computer for meaningful tasks. This shows that a computer system needs both software types to function effectively and meet users' needs. Imagine you are part of a team developing new educational software for students worldwide. Based on the software quality characteristics, which 3 qualities should you prioritize to ensure your software is effective and accessible for diverse users, and why? You should prioritize accessibility, so students with disabilities can comfortably use the software, localization, so the software can support different languages, time zones, and cultural formats, and usability, so students of various ages and backgrounds can easily navigate and learn with the software. These qualities ensure the educational software reaches and benefits as many students as possible globally, regardless of their abilities or location.
A time to remember. This is Teacher Mylene. Thank you for watching and please subscribe to my YouTube channel.